Thank you. It's great to be here. I am really excited about the kind of a practical application of data science. We get to talk to Dr. McCulloh about today. Dr. McCulloh is fantastic, and we're really grateful to have him with us. I will introduce Dr. McCulloh briefly. I guess first about me. I've been doing AI for a long time, kind of longer than I'd like to count, kind of in a variety of capacities. And I am just excited to be talking about the practical applications of AI and engaging people in the conversation. Dr. McCulloh is a really great conversation partner here, with also a range of experiences in technology. He was a lieutenant colonel in the United States Army, but it's all around AI, all around putting technology to use to keep people safer and I guess protect Western civilization. Dr. McCulloh, right? We can kind of say that. He was also a professor at Johns Hopkins University and some other fancy titles at Johns Hopkins. But now, chief data scientist at a division of Accenture, an impressive guy all around. Dr. McCulloh, off to you. And we also have some slides you're going to start off with in talking about kind of the practical implementations of data science.
Well, after that kind introduction, I feel like I should do the same for you. So Eric, yes, has a long, I can actually count how long Eric's been in technology, but I'll spare him that for now. But he was doing that as an undergrad at Carnegie Mellon and had to break after his sophomore year because his sophomore computer science project made it big, and he made a fair amount of money off of that. And then went and finished his degree, so he could go into venture capital for a while. And then after he retired from that, he was one of the founders of the Carnegie Mellon West Coast campus. And then eventually found his way to the White House, where he was a presidential innovation fellow in the Obama White House, leading a lot of their AI and robotics. And one thing that I just would like to point out as we're talking about real world applications, with all the negative media that you hear going on these days, there's a really hopeful good news story. And that is that under the Obama administration in the United States, they made a lot of great investments in AI and robotics that Eric was a leader in and heavily involved in. And normally when parties change, it's very common that all the ideas of the previous party are horrible ideas, and let's just reinvent the wheel. And we haven't seen that with the Trump administration. They've actually, at least in the area of AI and robotics, they've doubled down, and they're really putting it to work to improve democracy. And I love being a part of Accenture Federal because we're a consulting firm that largely helps America implement those advances to make lives better for our citizens. So I'm glad to be here today. Did you want me to go in with a story, Eric, on practical?
And thank you for the kind words, Dr. McCulloh. But sure. I will, yes, you dive right in, and I think we have some slides we're going to bring up for you.
Yeah, so I think one of the big things we want to focus on are what are the hidden challenges with big data projects, digital transformation projects. And so, Eric said I was in the Army, so I was doing artificial intelligence at the University of Washington in the late 80s, early 90s, and then I graduated and went in the Army. And my first day in the Army, I showed up, and they were fielding the computer you see on the screen for the first time. This was a 286 processor, which was developed circa 1982, fielded to the Army in the mid-90s. And so all that was on there was a Unix prompt, and this was the Aviation Mission Planning System. So fast forward about a year and a half, I was the only guy that knew how to use Unix. Go back to the previous slide. I'm sorry. So fast forward about a year and a half, I had been working with the Communications Electronics Command at the time, and we had it so that every time one of the helicopters would key its microphone, its radio, it would update a location of where that helicopter was on the map. And at that time, my leadership said, well, we're never going to have computers in the Army. That's ridiculous. We can't support the generators. There's not enough battery power. And so I would be forced to transfer the grid coordinates of the item onto an acetate map overlaying a traditional map, right? So fast forward about 10 years from the mid-90s into the mid-2000s, next slide. this is what our Army would look like. Now, keep in mind, the U.S. Army was newly into the global war on terror. So we're in Iraq and Afghanistan. And you see to the right there an example of a command post of the future. And you'll see that there's computers everywhere. So that we'll never use computers. We'll never have the battery power. It was a little bit of a misnomer. The command post of the future was attempting to apply traditional data governance, data architecture. How do we network all of these commands together to get relevant information to inform decision support for senior leadership? And there was all sorts of problems that everybody faces when they try and do these types of problems, right? Data quality, data integration, different data format. It could even be something like one of the problems we had is for what we call weapons technical intelligence. So when there's a roadside bomb, there were 128 different data fields that the type of power source, the type of explosive, the location, all of these different things. But how many soldiers know how to fill out those 128 fields, right? It was more fields than the soldiers even had the skill set to enter into the data, right? So there's all of these problems that they were having. Well, meanwhile, a major on a forward operating base was tired of answering requests for information. So he set up something like an internet cafe that allowed you to do this crazy thing like video chat with your family members back home, which was crazy. And that baited soldiers into this area. And they had this system called the Tactical Integrated Ground Reporting System, or TIGER. And all the soldiers could, in a secure environment, just put whatever they wanted about the patrols they were doing, about what they saw, what they knew. They could talk to the people that went on the patrol before, talk to the people that are going to go behind them. And this became the data system that everybody wanted to use. And so what ended up happening is, as senior leadership realized that all the good data was in the TIGER system, they wanted to start applying structure to that, so that it could provide the data integration and the single, common operating picture that that the command post of the future was using. And so what happened? Everybody stopped using the TIGER system, right? So General Casey, I believe, was in command of U.S. forces Iraq at the time, and made a very wise decision to say, you know what, we're not going to force structure on the system. We're going to hand this off to DARPA. And the Defense Advanced Research Projects Agency for the U.S. military started investing in artificial intelligence solutions to take unstructured data from this system and feed it into the command post of the future system for the structured data for decision support. So in doing so, you created a system that the data owners, the data users wanted, and engaged them. And that was where all the focus of that development was in. And then you used AI to structure it for decision support. And that was critical for improving situational awareness and moving things forward.
So, Dr. McCulloh, what are the lessons we learned from this? We learned that the top-down implementation of this technology didn't work. It was tried, but it didn't work, and the credit goes towards leadership to recognize that bottom-up data acquisition wanted to be generated by by staff on the ground, if you will, and the path was switched to recognize the value of that data that was generated, instead of continuing to try to reinforce this top down. Is that right?
No, absolutely. And I would go one step further to say, I call it governance versus engagement, right? But it's not that governance is not important. It's not that governance is not something that you need to do. Identify data owners, hold them accountable. But that's really designed for an organization that has control over subordinate elements. It's not enough. And I like to use this example because we think of the Army being a very hierarchical organization. And with all the military discipline, right, with all the hundreds of years of accountability, orders, discipline, hierarchy, right, if the United States Army cannot enforce data governance, right, how do you expect your organization in the corporate world to, right? It's not that you don't put governance processes in place. You just have to recognize they're not sufficient.
Right. So that's the useful little segue here, is that we have examples from government, in this case, the military, but this is really a global problem for all organizations. They'll have these sort of silos. They'll have the difference between the technology and just being human, reacting to the interaction with the technology. This is something that had been going on from the birth of those antiquated looking computers into the 90s and 2000s, and it's still with us today, right?
Oh, absolutely. And I think that's the important thing, is we have to recognize that creating data governance does not solve your data integration problems, does not avoid the need for integration. I'll give you another example. I'll go back in time from this slide, right? Back to the late 90s, right? So among data things, I was a special forces officer. And so I had a special forces team. And in U.S. Army Special Operations, they have a separate command that deals with acquisition and resourcing for the special. It's, I guess, the special and special operations. And so when you would do a mission or do a training event, you had a report. We called it SODARs. I don't even know what it stands for, but it was a report you're supposed to do about lessons learned from your mission. I never did it. I mean, I was an immature captain. I just never did it. And so eventually my commander would call me and say, you didn't do your SODARs report. So I'm like, fine. So I'd pick the sergeant that irritated me the most that week, and I'd say, go fill out the SODARs report. And he'd be like, wow, what am I supposed to put in there? I'm like, I don't know. I don't care. Just make it go away, right? And they would go and sit down and fill out the information. And you can imagine the data quality that is not just me, but like every other team that's now feeding the acquisition engine for U.S. Special Operations, right? Meanwhile, all the real lessons learned, all the teams that were my partner teams in our missions, right? We would share lessons learned off network, right? In our own data silo in a way that was shareable. Why? Well, for me, I could go and put in information about my mission into this SODARs report and never, ever see anything back for me that would benefit me as the user. And so if you draw your attention here to the difference, right? What is a soldier, right, that's getting ready to go on a patrol, and in this case, like potentially risk life and limb, right? What does he get out of that architecture on the right? Right? That's completely tailored to the executive leader that's trying to make decisions. And he's just expecting people are going to give him all their valuable data. The system on the left is much more about user engagement. And I think as we've seen the digital transformation occur in the global scale, not only do we recognize the value of that, I mean, that's how like social media companies make their revenue, right? Is by giving stuff to users for free, because the value of the data that they get on the back end is that valuable. I'll transition one more slide, then we can get rid of the slides and maybe get better close-up of Eric's charming face. So we go now from the mid 2000s to the 2010s, right, in there. And now we're starting to use artificial intelligence a lot more than just putting structured to unstructured text. So in this particular example, there was a mission for, as we know, extremists often will go online to promote disinformation and recruit terrorists and these sorts of things. So the U.S. government had a mission to monitor and identify and defend against that. And so this is an example of data that was pulled off of a given month of extremist forums. And so there was labor costs associated with native speakers taking a certain portion of their time to classify whether something was essentially extremist or, pro-democracy, so pro-extremist, pro-democracy. And so as I'm looking at that $4 million of cost and labor, I'm thinking, well, you know what? That shouldn't be that hard to build a classifier to do that. So I built a classifier. I called it my $4 million classifier, but it was a hybrid naive Bayes support vector machine, and it had 64% accuracy. And everybody's like, Ian, your algorithm sucks. It's barely better than flipping a coin. And I'm like, it's double digit better than flipping a coin, my friend. It is 64% accurate. But I decided, okay, what is human agreement on this task? Which wasn't done, because everybody wants to scale the volume of data by having different people look at different data sources. So I actually got them to pause, and for a month they overlapped and they rated the same data. So you had at least 2 people per data point. And we found that the agreement rate was 68% accuracy. And you think, well, that's horrible. And maybe it is horrible, but this was a number of years ago. But in light of today, right? what is pro-democracy? What is pro-extremism? Are those the only choices? What about neutrality? What if somebody says something about negative about Donald Trump? Is that an indictment against democracy? Is it for democracy? Is it even related, right? How do you fit that in there? And I just use that because it's unclear in a lot of cases. And so for this particular example, we are placing $4 million a year in labor for what? A 4% increase in accuracy, instead of addressing the human issue of why do people not agree? And how do you measure that agreement? And what we know is if you have consistency in your data labeling, that's necessary to have high precision. But if you take an inconsistent annotator and throw them out of the mix, right, that's going to decrease your recall, because recall is based on the volume of data points that you have. And so when we look at this harmonic mean between precision and recall in evaluating our performance, I would argue that we don't want to just look at arbitrary performance. We want to look at precision now by being consistent. But over time, you'll get more and more data. And as long as you're consistent, you're going to lead to a better solution. But how much time do we have in making sure we have that consistent agreement, right? And again, this goes back to the data quality. How do we make sure that label A is really label A and that everybody agrees it's label A? How do we identify those issues, right, and expose them? And that's where Eric's company comes in, right? Because they can help highlight some of these issues so that you we call it technical debt, right? So if you let your organization proceed down the path of digital transformation, the longer you do so without addressing data quality up front, the more technical debt you incur, and you can't recover from it. And on that point, like if I let the labeling go for a long time at 68% agreement, right, I can't use that data to have higher performance than 68% accuracy in the future.
Nice segue, Dr. McCulloh. That's really good. I think we're done with the.
That's why you invited me.
Yeah. I mean, if we're talking about kind of solving these problems of having more data being the problem, I guess the one way of talking about what Accenture does, what the work of a chief data scientist does, is pointing out that really all 21st century businesses are AI businesses or tech businesses, because they're all going to be data driven, right?
Yes, we've seen. I sometimes say in the signature block of my my email address is data is the new oil, but it needs refinement to fuel your business.
It's a good analogy. Yeah, good metaphor. Yeah, I heard the same thing around mining. You're going to get some rough stones, and you gotta still get to the good stuff.
Yeah, everybody. I think everybody today recognizes that you don't have to make the same argument that I did in the early '90s, right? That no, computers are going to be a thing. We should use them for decision support. You shouldn't make me transfer them to a grease pen and a piece of acetate map. But I think where we're at now is, while people know that technology is important, while we're in this next wave of AI where people are looking to use it for decision support, there are some basic things that I think every executive should know when they're making investment decisions and resourcing decisions, right? Risk decisions. And one is that your volume of data alone, it's not about having more and more data. It's about having the right data. And oftentimes that definition of what right is highly dependent upon how it's classified.
Totally. That's a really funny. I so often when our firm, we're kind of bringing more data to bear to be useful, right? Useful and accessible. We find people just think they want just more data. It's like, I want the refined oil, or I want the needle in the haystack, and what people give me is more hay. It's like, I don't want more hay. I want more insight. I don't want more just data. I want more wisdom.
Well, right. And the first thing you're going to do as a data scientist with more data is you're going to take a subset of smaller data, right, to work through what your data model is. What are the fields, right? What is, ultimately, I follow this acronym I call the road to success. What is the requirement or research question that the client wants to know, right? Let's neck it down to a tangible, bite-sized piece, a requirement that they want to know. Then I look and say, how do I operationalize that with data? And so what do I mean? Well, I look at the data that's available. I look at the data fields that are there. That's part of it. Part of it is, do you agree that this data source answers this question, right? If I want to model coronavirus, for example, right? Do I agree that the data that's publicly available on the Johns Hopkins data source site of coronavirus cases is suitable to answer trends about coronavirus and when you should open your commercial stores, right, for business? Then what's that method of analysis, that analysis methodology that you're going to do, given the research question, the data? And the hardest part at the end is the D. What decision are you going to make, or what are you going to do with the data? And that oftentimes will revise the other pieces. So when we talk about big data, it's really giving us more options in the O for operationalizing data.
That's fantastic. You're in Washington, D.C. I'm in San Francisco, but I think a lot of the people listening right now maybe got a GMT plus or minus an hour, so it might be around dinner time, supper time. But we have a poll, I guess, that we're going to push out now to everyone about where they are in their data science journey. So what's the issue about data science? They're experiencing it. And this is really good. All of the above I like is winning. I have all these issues in the ecosystem that is data. I like the acronym you just brought up, Dr. McCulloh. And I have a similar one, which is sort of the that we're both familiar with, just the definition of a robot, which also applies to data, which is sense, plan, act. Right? You have to collect your data. And that can come with sensors, and that's just going to get worse with IoT. You have to bring that into your system, and that part of the data integration, data migration, data transformation story, and then only then will you then be able to analyze it to make better business decisions after those first two components that are often neglected. And then when you do the analysis, you're going to ultimately make a decision. And then that's a rich source of conversation for the two of us to have. So that's a terrific poll. This is like a race where these polls are going to be changing over time, but all of the above is winning. So that really gets to your point, Dr. McCulloh, where what you guys do at Accenture is you're working on that whole ecosystem. What my firm does at Conexus is we're helping with that provable intake. And we'll keep that poll up, I guess, while we continue to chat about this. Is that whole intake that people often don't appreciate. Our firm, Conexus, is working with Accenture, because what we'll help do is we'll be the only ones that can help make data available and usable. And at the rate of data growth is really the big issue. And I think we'll get Dr. McCulloh back in a second. At the rate of data growth, and there's really no other solutions for bringing data integration, data migration, bringing data to bear at the rate of data growth. There's no other solution for that. And I know, Dr. McCulloh, we can talk a little bit more about this, but I'll say one more thing about it, because people often ask why, what's changed, what's different, and the answer to that is the math. And so you and I have been trained in computer science, but the computer science in this domain has really reached its limit in many ways. That the computer science that we've been trained on is based on the math that we've been trained on, and we're used to revolutions in physics that kind of keep Moore's law in its continuity. We are less used to revolutions in mathematics, and what we find is the math that was invented in 1970s, relational algebra. They kind of created this relational mathematics, and then we gave us relational databases, many of which were founded in 1977, has really reached its terminus because it hasn't kept up with the rate of data growth. The RDF and OWL are two technical terms that came about in the early 2000s to try to address this, but it's been a friction for many of the businesses with which you interact, because they've been hampered, they've been impeded by the inability to integrate, migrate, bring to bear data at the rate of data growth. And you're seeing this. That's really what you're articulating, Dr. McCulloh.
Well, yeah, and forgive me for one last military example, and then I'll be done with that. Is really the biggest innovation that I think we had in intelligence, military intelligence in the war on terror, came from relational algebra. Came from this area of mathematics of dealing with the relationships. And so what it allowed us to do is take forensic data that we would pull off of roadside bombs. And instead of identifying who the leader of a terrorist cell is through traditional, James Bond-esque, spying and whatever, we were able to take forensic data, and we're able to understand informal leaders, like who are training people to make bombs, and what are the, what is the supply chain, for explosives, right? And so in doing that with relational algebra, it allowed us to revise our targeting so that we were able to arrest and capture the people that were actually causing the problem. What I think your solution, Eric, does that's a little different is it takes category theory, right, which is the next evolution from relational algebra. So, again, my criticism with the military, it was like, circa 2009, 2010, we're using 1970s math, but, the math that we should be using now is probably 1990s math, right? So category theory kind of allows you to say, instead of this field equaling this field is similar to this field. And in doing that type of relation, it allows you to go across very disparate data sources, and it allows you to have better scaling and better efficiency. So it's maybe a slight compromise in a small percentage of accuracy for a huge gain in performance in that data integration task.
Yeah, like what I like to say is that math, relational math, we'll call it, relational math worked really well for when our ancestors were in the farms or were in factories. It's good math for those contexts. But in a digital world, it just doesn't make sense because you don't have continuity in a digital infrastructure. And categorical math, and I like to say it is the math of relationships, is kind of where it's going. Set theory, graph theory, and categorical mathematics, category theory is really the math of the future. It's really like a language where Latin was useful in its day, but not quite so useful in the modern way. It's still interesting, has kind of niche applications, spelling and bonus and etc. are good words we still like to use, but just less useful. Many of the technology firms that were very powerful will become less so. HP and Cisco continue to exist. They're just not relevant in the way that they were 10 or 20 years. And so the leaders in the future will be taking advantage of this categorical mathematics, this sort of relationship math. And I loved what you said, Dr. McCulloh, which was the math of sparseness. As the data begins to explode, or continues to explode, kind of at the rate of like maybe the metaphor, our universe expanding, it becomes more sparse. When we were, go ahead.
Well, I was going to say, one of the things that strikes me as I hear you talking about it is, we were training, I've trained hundreds of people on, probably thousands now, of people on like some of the basics of relational math. And what strikes me is it's not really harder than calculus, right? But our math education is all oriented around teaching people ultimately to do calculus and then engineering, and essentially those mathematical problems assume independent, identically distributed data. Every data point is unique and it's a self, right? It has no bearing on any other data points around it. And so if we sample that and we get enough of it, then we can just find the big patterns in the data. Well, when dependence occurs, right, when a data point is dependent upon the data points around it, right, then the fundamental assumptions of all the math you're doing break down. And that's where it's important to, it's not a harder math, it's a different math. It's a math that our education system is not built to teach and not built to train. And therefore, when you look at all the things in technology that you have to learn, right, it becomes one of the easiest things that drops off. And I think that is the biggest obstacle, not because it's necessarily more important, but it's less used.
Right, and this is a perfect example, right? I mean, just like many things in the world, all these institutions that grow up have their own constituency that are kind of resistant to going away. And you might say, oh, the more math, the better. But I mean, if I were to choose, I would get rid of geometry, trigonometry, even calculus, and have people learn probability and category theory. It's really the math of the future. It's really where we're going. So the sparse data issue, I can hit on.
I just have to say, right? I actually in Florida here, where I've been living, they have a Great American Teach-In, they call it, where they ask people to come in and just teach. So I've actually gone in and taught relational math to middle schoolers at 7th and 8th grade, and they love it, and they get it. And then the teachers are like, oh my gosh, these kids are doing like dimensional analysis and linear algebra in like the 7th and 8th grade. You can do it. I totally agree with you, Eric. I didn't mean to interrupt.
No, thank you. One of our co-founders is a faculty at MIT Math and has pushed down category theory into high school level. So it no longer needs to be at the graduate level, and it's going to like just permeate society over the next 10 or 20 years. Categorical mathematics. So sparse data is growing up, and I'll share a little example that you're familiar with, Dr. McCulloh, which is one of the deployments that we've done with a big ride sharing company. 4 letters. We won't divulge their name. Where they've done a lot of rides. More rides. You can put in all of your heads about how many rides you think they might have done. It's probably a bigger number than that. It's like stars in the galaxy sort of numbers. And more to the point, besides the number of rides they've done, this company they have a lot of schema or models. And so you might imagine if they were trying to analyze London's correlation between driver performance and the weather, or the rates could be charged relative to the weather to riders. They could analyze that for London. They could analyze that for Brighton, but they couldn't bring those together inside of one model. And as the data became more sparse, they wouldn't have all information about all things. As it became larger and larger, they would start using these structures called knowledge graphs, which you're familiar, and many of our listeners will be. But those couldn't be brought together for 2 cities, let alone the country or the continent or the world. And for all of these businesses that kind of have high velocity turnover, let alone those who have small margins, increasing just a little bit can mean tens of millions of pounds, tens of millions of dollars of improvement, per year. So this ride sharing company was trying to model all of this data, billions of rides, and they couldn't do it. You talk to the technology head at this firm, they didn't even know that this was a problem 4 years ago. Gets to our point about this kind of being an emerging issue. So this is a leading edge company with kind of seemingly infinite resources, and they didn't know that they even had this problem. But they kind of looked around the world. How do we model all this stuff? How do we have sparse data in this world where it's the new oil, but data needs to be mined or refined? And they knew they had to go with a different sort of mathematics. That's the only way to do it. They couldn't rely on the mathematics of the 18th century, and we were fortunate that they came to our firm to try to model all that data to make the data available, usable, and then make better business decisions.
Well, Eric, we've been talking about the benefit of relational math and about engagement, about how do you get users to put their good data in, kind of within an organization, whether either in the Army or within your 4-letter ride-sharing company. But there's another application where this is very important, and I'll just take an example of something that should be on everybody's mind. We're all dealing with the impacts of coronavirus, and so if you think about the importance of the data that's coming out of that, right? Companies, some of our federal clients and our commercial clients are looking at, when do we open our doors for our business? Are we protecting our employees, right? What's going to happen with the virus? Has huge economic impacts, safety impacts for people, right? So when we actually look at the data, probably the most authoritative, publicly available data source is Johns Hopkins University's coronavirus tracking. There's a few others. I'm not trying to narrow in on one. I'm just using this as an example. But if you think about that in the US, there's about 3,000 counties in the United States. Each county has a public health department. Each public health department is going to have a different acquisition process, so probably a different solution for what data they collect, what platform they put it on, what method of analysis they use, not to mention interacting with multiple HMOs. We have strict privacy rules against medical data. Plus, how many people that have coronavirus in the United States, there's so many people that are asymptomatic. How many people actually go to the doctor? If they go to the doctor, are they tested? Right? All of these factors add complexity. And it is probably absurd in light of that to think that there would be a single platform, a single solution, and it's not even worth entertaining the idea that you would even attempt to have strict governance or data owners, right? You don't even know who data users are. I have a paper under review right now that estimates our tracking of the coronavirus case is probably about 6 to 10% of the actual testing, right? We have a really nice validated model in New York City that hopefully will be getting published soon. But with that area, how then does a public health or a government or a company, commercial company, get their arms around that coronavirus issue? And you've got to realize that data integration is not something you can govern away. I'm not saying that you should not think about governance, right? I just make that point clear. If you own a data, a platform, if you own, you're designing an enterprise architecture, like you've got to think of governance, right? Because why just let it arbitrarily be hard? But you just can't. You can't assume that that's going to eliminate your problems. You will increasingly have data integration challenges. Period.
And thank you. You're speaking our language. You're going to have problems bringing the data together. People.
That's why you asked me here, right?
Making data available, making data usable. That is a problem of our time. We have the polls we're going to bring up and see where we stand on this about what are the issues in your company, and we still have the winning issue. All of the above. I have an issue that we can talk about to make this point. We are talking to this really large logistics company, and I didn't actually know how big these logistics company could be. I didn't realize, tens of thousands of employees, and they asked our company to be asking about a client of theirs that also had tens of thousands of employees. This company, their client, had then hundreds of ships around the world, a fleet of ships, container ships, that then each one of which had tens of thousands of these shipping containers. Inside of those were boxes that contained the personal protective equipment. It's the reality of our world, right? Stuff's just distributed around the world. And in a world where, in January, February, we could have gone on Amazon and had some chrome dumbbell shipped to our house within 48 hours, then, it seems kind of incomprehensible that this client of ours, and their client more specifically, couldn't find out where their stuff was or where their client's stuff was around the world, but they couldn't. And they wanted to know where the personal protective equipment was. And do I send it to Seoul or London or Houston? Where is it? But it took some delay, like sending a command to the Mars rover. And this impaired their ability to respond to this current crisis. And so what we were able to do, and about these sort of deployments, is we were able to integrate. We're able to bring all that data to bear, even if, as you're saying, Dr. McCulloh, the data is scattered, even if it's in silos, even if it's the data just kind of naturally goes towards complexity and having different people in charge of it. How do you bring all that data to bear so you make decisions more quickly, you have it available to have better analysis and make better business decisions? So we have one more poll. Can we bring up the second poll? Is where people are in their data journey. I think just to get a sense of where people are. And it's a lot, right? So we're early stage in formulation, consideration. So we have that, and then just the other, just the morass of other. What are my considerations around data, and what are the problems there? And those problems can happen many times. And I know we just have a couple of minutes left that we're going to take a break and go to a Q&A.
Eric, if I could add, the one caution that concerns me about this is almost like I would say 90 to 95% of the clients I talk to are concerned about the data, and they're concerned about the platform and how do we move everything to the cloud. And essentially the cloud is somebody else's computer, right? I mean, like if but with some differences, right? So if all you're doing is taking what we have in an on-prem system and moving it to the cloud, then if you have a horrible on-prem system, you now have a horrible cloud solution, right? So there is some things you need to think about with the architecture as you're moving that. Don't try this at home, kind of thinking. But the other piece that I would say is you have to think beyond the data. And that's what that road to success is, right? Is you've got to think about what are the requirements or the research questions, the questions you need answered. What data then is going to provide insights, and prioritize that data? What method of analysis are you going to do? What decision are you going to make? Get that straight before you start anything. Before you start anything, because you otherwise are going to waste a lot of money and resources in things you don't need. I'll give you an example. An F-18, when it goes on a flight, comes back with petabytes of data, right? I mean, everything from the wind speed and the temperature and the I don't know how much the little wings wiggle, and all this data. And the vast majority of it, nobody's going to use for anything. So are you really going to spend that extraordinary amounts of money to upload that data to the cloud, to store that data in the cloud? What are you going to do to process with it? I mean, what are your compute times, right? We found tremendous savings, by the factor of I don't even want to throw out numbers. I mean, we looked at a process that just pre-reads citizen benefits applications to help identify who actually deserves their citizens benefits, right?
Dr. McCulloh, we have one more minute left.
Okay, sure.
One question for you, or maybe two, but one question. How do you decide if it's more trouble than it's worth when dealing with a data analysis project?
Well, I go through the road to success first.
In 1 minute, yeah.
I go to the road to success.
The road
first.
to success, that acronym,
and I
the
say,
whole system. What
decision am I going to make, or what action am I going to take? And if you can't define that, don't go down the cost of a data analysis project. If you don't know it's like I don't waste a medical test if it's not going to inform treatment, right? Why am I going to invest in a data science task if it's not going to impact a decision or an action?
How is it going to do it? And that's why we have the perfect marriage, because what we do is we make sure that your data is available and usable at the rate of data growth. That was perfect. Thank you, Dr. McCulloh. And so we'll have Q&A. We'll be back. We're going to have a short break, 15-minute break, I think, and then we're going to have a Q&A. And I think in that we're going to talk about applications M&A. We're going to talk about policy preserving queries. And I think Dr. McCulloh also has some fantastic other stories to share. And last thing, Dr. McCulloh, how do people reach you?
You can Google me.
Google you. Okay, fine. And for me too, I'm on LinkedIn and Conexus.com. We have our, you can find information.
But you should find my email. Whether you want to hit me up at Johns Hopkins or Accenture, either way.
Very good. Thank you, Dr. McCulloh.
Want access to more CogX videos? Subscribe now for free at cogx.co.